Hi, kids. All right, here is electric circuits basics number 3, part 3. Yay! This one's gonna be about voltage. Okay, so what is voltage? Voltage is electric potential. It is sometimes called potential difference. And it is the electric potential difference that causes electric current. Sometimes you can think of it like it's the push that's pushing the charges through. You can think of it like that, and that's okay. But without a potential difference, you will get no current. We use the water analogy. So if you think like, hey, I have these two ponds that are like this, or I have these two ponds that are like this, or I have these two ponds that are like this. Well, these two ponds, there's no potential difference. There's no potential difference. No water is going to flow. This would be like you have a dead battery. This would be like, hey, there is 0 volts. Well, if you look, do you see how there's a bigger potential difference here than there is here? So, sorry, bigger potential difference here than there is there. So if this has a bigger potential difference, then for the same resistor, if I have the same resistor, remember our resistor was like a water wheel, so if I have the same water wheel here, well, the current is going to flow a lot faster here. It's going to be a lot more here than it will be here. Why? Because there's a bigger potential difference. So voltage is like this potential difference. Make sure that makes sense. It's so important that you can conceptualize that. Now, voltage, the unit for it is a volt. That's true, it is. And remember, a volt is really a joule per coulomb. That's going to be important in our next video when we talk about power. But a volt is really a joule per coulomb. And our equation, remember we had this for current. I like to write it this way, and this is why I think physicists used I for current as opposed to C. Well, they use that for capacitance, but because then using it like this, that makes this a very nice equation. Now, the College Board writes it this way. This is how you're going to see it on the equation sheet, because the College Board always likes to say things like, hey, this variable depends on this and this, where in reality, the voltage depends on how far apart your ponds are. Like, how big is the potential difference? It really doesn't depend on I and R. I hope that makes sense. Like, where current really does depend on this and this, but this is typically how we're going to use Ohm's law. Remember, this is Ohm's law, which is just a very nice way of using it. So it's very nice. All right, so let's then talk about this. We're going to draw some circuits and talk. So let's say I have this circuit, just a basic circuit like this. If I have a basic circuit like this, actually let's do it like this. So we'll put 2 resistors. There's only one path. This is going to be called a series circuit later on. But if you take a look, this green would be my high voltage line. This would be my high equal potential line. The red would be my low equal potential line. Remember, what does equal potential mean? Same voltage. So everything along this red has the same voltage. Everything along this green has the same voltage. And this purple would be like my in-between. That would be my in-between potential line. So one way, if it helps you think about this, let's do this with our stair analogy. So if we do a stair analogy, imagine that you have your battery. So your battery bumps things up to, so this is my battery. Okay, and then I have my high equal potential line, which we said over there is green. Okay, green. And then I am going to go down some stairs. You'll notice I don't go down all the way. That resistor uses a little bit of the energy, because again, energy per charge, okay, so that it lowers it a little bit, which means now this is my intermediate equal potential line, and then my last resistor is going to lower it the rest of the way, so that this would be my low equal potential line. So if this was R1, and this was R2, and this would be R1, and this would be R2. So then, if you had to write an equation that relates this, well, if I call the battery voltage the total, well, on my picture here, that's the total. Does everybody see it? Okay, so this is the total. Well, that's going to equal this plus this. Oh yeah, this plus this equals this, which is, if I was to write an equation for that, it would look like this. Okay, why? Because as you go around, okay, your voltage has to add up. That's the loop rule. Okay, we can do the loop rule a different way as well. Let's say I wanted to do a slightly different. Let's say I start at this point, and then I walk around clockwise, okay? So if I start at this point and I'm going to walk around, well, I am starting right here. I would go up VT, everybody sees it, and then my resistor is going to lower the voltage, so I would go down I times R1, everybody see, and then I get to here, and then I would go down I times R2, and this I and this I are the same because there's no junctions, and then hey, I get back to my starting point. That means my change in voltage has to be 0. That's the loop rule. Any loop you take around, your change in voltage is going to be 0. Okay, so I went up, and then I went down, and I end up back at my starting point. Okay, everybody follow that one? All right, I'm going to do a couple more examples to make sure we got it. So let's do a little bit different example. Let's try this one where it's like, all right, so I have, this is my circuit. Okay, where this is my total. This is R1, this is R2. So again, let's use our colors to show the different equal potential lines. Well, in this case, here's my green. Green is my high equal potential line because it touches the positive side of my battery. Okay, this is my red. This is my low equal potential line because it touches the negative side of my battery. And you'll notice there is no intermediate for this one. Okay, because it's a different circuit. This is called a parallel circuit. But you can see that if I was to use my step analogy with this one. All right, so here's my battery. So I go up. Okay, there's my battery. And then I have my high potential. So here's my green one. Well, if you look, there's 2 different ways to get down. So I need to have 2 different ways to get down. I could either go R1 or R2, and then this would be my low equal potential line. So let's use this and write out my voltage. Well, look, my total voltage, that's the same as the voltage across R1. And that's the same as the voltage across R2. Notice how I'm saying across, because when we measure it's always across 2 points. Okay? but my total voltage. So in this case, it would be VT equals V1 equals V2. Now remember, we're not memorizing this. We're making sense out of it. Okay? Now, if I wanted to write my equation, okay, again, let's say I'm going to start here and I'm going to go around. Now, any loop that I go around, so let's do this loop first. We're going to kind of go the inside loop going around, okay, that inner loop. Well, if I go around that inner loop, first thing I encounter is my battery, plus VT. Then I encounter my resistor. It would be like, hey, I'm going this way. Oh, I'm going this way. Minus, now this is where you have to be careful, okay? It would be I1 times R1 and then equals 0. Why do I have to go I1? Because the I here is not the same as the I here, which is also not the same as the I over here because current is different, okay? Hopefully we follow that okay? So, or if I wanted to go the outer loop, let me erase this one. Okay, if I wanted to go the outer loop, so let's go the outer loop around. In that case, it would be, well, I encounter the battery, I encounter the second resistor, and then I am back at my starting point. Okay, so again, you notice I wrote I2. Why? Because the current here and here are not the same. Or you could also do this loop. Does everybody see that? I could go around like this. So let's talk about this one. This one's a little weird, okay, but it's not that weird if you think about it like with this. Here's what I'm doing. See this loop? This is this loop right here. I'm going this way, here, and then there. That's my loop. Does everybody see it? Well, all right, let's write our equation. The first thing I encounter is this. You see I'm going with the current. If I'm going with the current, I'm going to drop voltage. So if I was to write my equation for that top one, it would be minus I2R2. Now, I'm going back the wrong way. Oh shoot, if I'm going the wrong way, that means I would have to add I1R1 and I would get 0. Hopefully that makes sense. Okay? Again, for that reason, we're not memorizing, we're understanding, we're thinking about what's happening here. I went down and then I went up. I went down and then I went up. Okay? Is everybody clear? All right, let's do one more example, make sure we really got it. All right, so let's say we have this circuit. Okay, this is more of a combination circuit because we're going to learn about this later, but this is a series and parallel. Okay, if I call this R1, R2, and R3, and this is the total. Okay, if I was to draw this with my steps, because again, it's important to be able to conceptualize. So like, I have my steps. This is my battery, okay? Then I have R1. Actually, let's do my colors. So everybody see this is my high potential. Everybody see this is my low potential. And then this would be my in-between potential, my in-between voltage. When I'm saying potential, I could just be saying voltage as well. And then, so with this, I'm going to go down a little bit. So here's my green. I'm going to go down a little bit to my purple. And then I have two different ways to get to red. Where this would be R1, R2, R3, and red would be down here. Okay. So if I wanted to write my equation, everybody ready? Look, total equals this plus this. So if I was to write my equation, it would be, hey, V total equals V1 plus V2, or V total equals V1 plus V3. Why? Because V2 equals V3. Hopefully that makes sense. Think about colors. I'm going purple to red. They have to be the same. Are we okay? Now if I wanted to do my loop rule, okay, so that if I was to go around, so let's go around the different ways. You ready? I'm going to go around this inside one first. All right, if I start here, I encounter the battery. So I go up. I encounter my first resistor, and you notice I'm writing I1, R1, because this I is different than this I and this I, because we understand current, okay? And then I encounter I2, R2, and I end up at 0. I could go the outer loop, plus VT minus I1, R1, minus R3, R3 equals 0. Or I could do this loop here, just like we did, okay? But in this case, again, it's going to be kind of weird. Think about your picture. I'm going down, across, and then up. So if I was to do that loop, okay, it would be, hey, I'm going to encounter this. That's going down, minus R, I3, R3, plus I2, R2 equals 0. Okay? Please understand. Don't try to memorize all this. Okay? Bye, kids.